One of the core pillars of chemistry is the law of conservation, that of balance. There are many different things that are conserved within chemical operations and even physical operations. The law of conservation of energy basically says that energy is neither created nor destroyed, it is simply rearranged. So, the implications for a chemical reaction, if a chemical reaction absorbs or expels energy, that tells you that the energy of the reactants and that of the products are not the same. Atoms or matter in general is another thing that's conserved. A balanced chemical equation is a great illustration of this because on each side of the equation, let's look at oxygen. There's two oxygen atoms on each side. There's the same number of atoms on each side for a particular element. That holds true whether we have 1 unit of reaction or we have a mole of reaction, anything like that. The law of conservation of mass is a great extension of the law of conservation of matter because on a balanced chemical equation, if we have the same number of atoms of a given element conserved on each side, each of those atoms have a particular mass, it makes sense that the mass is also conserved beginning to end. Now, I'm not going to go over this example that's here. Really, the true value of this section, there usually is not going to be a problem that says use the conservation of blank to determine what this is. It's more so implicit within the problem. Like, say that you want to figure out the identity of an unknown compound, you have like stoichiometry and everything. Knowing that the law of conservation of mass exists is simply another tool that you can apply how to solve the problem. The law of constant composition isn't necessarily about conservation, but it is very much related to it. Let's say that we have a given sample of H2O. No matter how big or how small that sample is, we will always have 11% hydrogen and 89% oxygen. That's because in a given unit of H2O in a molecule, we have one O and two H, each of them having their own specific grams. So if you just have more of them, you have that same ratio. It's just scaled up to bigger amounts. It's always going to be 11% hydrogen by mass and 89% oxygen. Let's do some practice questions because I don't just want you to listen to these concepts. I want you to try them out and really learn by doing. An exothermic reaction is one where energy is released as a byproduct of the reaction. If a reaction causes 100 joules of energy to release from the system, what is the relationship between the reactants and the products in terms of their relative energies? Number two, why is the law of conservation of mass directly inferred from the law of conservation of atoms in terms of chemical reactions? Number three, the mass of oxygen in a 10-gram sample of H2SO4 is 6.35 grams. What is the amount of oxygen in grams in a 200-gram sample of H2SO4?